Hi, and welcome to paper 2 of the Leaving Cert Maths Ordinary Level for 2021. And we're looking here at question 3. So if you want access to the notes I'm working off, just send me an email at shanetroy@gmail.com, and that should be in the description below. And if you like the videos, just subscribe, you get access to all the playlists. So question 3 here is looking like a coordinate geometry question. You've got coordinates here. Okay, so you have an x and a y, and an x and a y. It says a line n passes through these points. Now, I'm not being asked to graph it, but even though this is not going to be the best graph in the world, -1 on the x, 2 on the y might be somewhere up here. 0 on the x, -2 on the y is somewhere down here. So I know this point here is crossing the y-axis. So that's a y-intercept, and it's looking something like that. Okay, so it's got a negative slope, and it's fairly steep, so it should be a pretty big number. It says then write the equation of n in the form y equals mx plus c. Now m stands for the slope, okay, and c is the y-intercept. Now we know the y-intercept already. We know that c is equal to -2 because we know this point here. We just need to know the slope. Now if I want to find the slope, I could use the graph itself if I drew carefully, but I can use the slope formula. So slope is equal to the difference in the y's divided by the difference in the x's. So sometimes it's called rise over run. Now I gave my coordinates x and y's up here, but I'm going to give them numbers. First x, first y, second x, second y. So once I'm at this point, I'm going to have to substitute into the formula. So this is where we get into the heavy lifting. And if I keep my equation going, so I'm not going to do it to the left-hand side, but I am here, instead of y2, I identified as being -2 as the coordinate. Now, I maybe should put it in brackets, but it's not going to get affected by anything else, so it won't matter here. But if I was substituting a negative number in here after the minus, I would put it in brackets so that I remembered that the sign's going to change. So that's minus, now y1 we said was 2. Now on the bottom here, so x2 we identify as being 0. Okay, take away the x1 value. So this actually is where we would need to substitute in a negative number. So the next line here, the minus by minus here, is going to change. So going left to right, okay, so slope is equal to, on the top here, -2 minus 2 is the same thing as -4. 0 take away -1 is the same thing as 0 plus 1, which is the same thing as 1. So it's -5 over 1, and divided by itself is equal to, divided by 1 is equal to itself. Okay, so slope is -4. So in a sense, I'm already done here. I have the slope, so I can fill this in, and I have the y-intercept. We found that from the logic of the question. Now if I actually do that here, so I'm going to substitute, instead of the m, instead of the c, I'm going to substitute the -4, and then substitute it's a -2 plus by -2 is going to change that to a negative. So my equation is y is equal to -4x, -2, take away 2. Now the reason I like this way of expressing a line as a slope-intercept form is that when it's in this form and it's y equals everything else, so 1y equals everything else, and you may need to rearrange an equation to get to that point. But once you have it in that format, the number in front of the x is the slope, the number at the end is where it crosses the y-axis. And that can tell you an awful lot about an equation. Like for example, if I made up one here, y is equal to 42x plus 3. This is a slope of 42, okay, and crosses the y-axis at 3. Now, always remember, slope means something. Slope is a measure of how much y is changing relative to x. Now, y and x don't necessarily have to be two random variables. They can mean something. One example I like to use is like heart rate versus age. That's a direct relationship, and it's linear. So it can be described by one of these type of models. Now, that's just the answer there in the notes, and hopefully there it's showing the points. Yeah, similar to what we did now, we graphed it better, or worse, worse by hand than the graph here looks. So we'll move on. Now part B here says the diagram below shows the line L. Okay, so this is it. Has the equation 3x minus 4y is equal to 5. So that's, and I can see here we have the point P, which is the one down here, 6 on the x, minus 3 on the y. So 6 minus 3. Okay, so part 1 then says find the equation of the line K. So this line we've given is called L, is a new line K. It's going through the point P. So I have a fairly good idea what's going to happen here. That is perpendicular, okay, to the line L. Now, perpendicular, okay, well, I suppose once I see a point and I see the equation of a line, they're probably going to ask me to find it. Once I see the word perpendicular, okay, to the line L, so this is the line L, perpendicular comes off at a right angle. So it's probably looking for an equation of line, something like that, okay, and that's the line K. Now, to find this, there's a few steps. To find the slope, I need to use, to find the equation of K, I need to use the slope and a point. I don't know the slope. If I had 2 points on K, I could find the slope using the slope formula, but I don't. So I have to adapt. Okay. So I can do it over here. Well, this is the equation of the line 3x minus 4y equals 5. Okay, so that's the line L. Now, if I can find the slope of this by comparing this to the general form y equals mx plus c, I can read off what m is. I can find out what the slope is. Okay. Now, I suppose the simplest way of doing this would be to just take the equation. Now I'm going to say I want the y to stay where it is on the left. I want everything else to move. So the 3x here, I want to get rid of it. So I'm going to take 3x away. If I do that to one side, I must do it to the other. So once I do that, okay, I end up with, now I'll do it over here, minus 4y is equal to 5 minus 3x. Now I can leave it like that, but like usually we write the x first. Let me just rearrange that. Okay, it doesn't matter. And you could say minus 3x plus 5 is the same thing. So in a sense, I've just rearranged them. There's no signs changing because they're just moving around on the same side. Now again, I still want to compare this to y equals mx plus c, but at the moment it's minus 4 times y. So I need to get rid of that minus 4. Now the simplest way to do it is to divide it by itself. Minus 4 divided by minus 4 will give you 1. Now remember, in algebra, I can do whatever I want to an equation, as long as it makes sense and is helpful. Like I can do bad things and make my life harder, or I can do things to get myself closer and closer and closer to a number, to a simplest form. Now, this one, okay, if I'm dividing this by minus 4, I must divide every other term by minus 4. Okay. Now, I've created a problem here, but I can just go left to right and simplify it. Minus 4 divided by minus 4 cancels and give you y, which is what I want. The minus 3x divided by minus 4 is the same thing as 3 over 4 times x. Minus divided by minus is positive. Okay, so that's why I changed it to a plus. And then 3x over 4 is the same thing as 3/4 times x. That's, I suppose, so I won't go down that road. On the last term here, now plus 5 over minus 4 is the same thing as minus 5 over 4. Again, I was doing all this to find the number in front of the x. So the slope is equal to 3/4. Now once I have the slope, this is the slope of L. Now I want the slope of K, which is the perpendicular slope. And the easiest way to find the perpendicular slope is to turn the fraction upside down. So the perpendicular slope is the same as 4 over 3. It was a positive number, change it to a negative. There's a way of doing this. You can have, if something's perpendicular, you can solve the equation one slope by another is equal to -1. And if you have 3/4 times the other slope equals -1, you can solve that. You end up with minus 4 over 3. So the end result from that complicated way is going to be the same answer. So this faster trick way helps us out. Now, we did all this in order to get a slope so that we could find the equation of the line. And if we use the other format, the y minus y1, I'll show you in a second, and we have a point and the slope, we can find the equation of the line, which is ultimately what we're trying to do. Now, by finding the slope here, we got a chunk of marks. So we're always gaining by doing work. Now I've run out of space there, so it's going to come to the prepared answer, and that's where I left off with the minus 4 over 3. So we can use the equation, the point slope form of the equation of a line. All I need is 1 point. Okay, the y and the x here stay in the answer, so they don't get substituted for. And we then want to substitute in the slope, which is m, and the point, which again was, what was it, 6 minus 3. We were given that in the question. Now, I can label that first x, first y. So I'm substituting the minus 3 in brackets for the y1. I'm substituting the 6 for the x1. I'm substituting the minus 4 over 3 for the slope. And once I get here, okay, it's in a sense a problem for myself. If I want to simplify it down, the one way to do this is, like, I suppose the 3 can multiply this way and the 4 can multiply this way. There's a lot of algebra steps in there, in a sense, but that's ultimately a quicker way to get it done. In essence, in reality, I'm multiplying everything by 3 in order to cancel this 3 on the bottom. Okay. And then eventually, once that's done, and I've gone the way across, I'll be multiplying by 4 into the bracket. Okay. Negative 4 actually into the bracket. So if I multiply the 3 this way and the 4 this way, in essence, I'm doing the same thing. Okay. But it's a bit of a stretch. So here, 3 by y is 3y, is where I get that. Now, minus by minus is plus 3. Times the 3 is plus 9. That's where I get that. I said the minus 4 will go this direction, so minus 4 by x. Actually, I don't do it here. I'll leave it to the next line. So on the next line, the 3y doesn't change, the 9 doesn't change, but I'm only doing the bracket bit here. Minus 4 times x is minus 4x. Minus 4 times minus 6, minus minus is plus, 4 6 is 24. Now, once I'm here, in the leading step, they usually want the answer, everything on one side, okay, x being positive. So for me to achieve that here, I need to move the minus 4x. It's negative here, so I want that positive. Simplest way is to bring it over. Now, if I want everything on one side, I'm going to have to bring over the 24 as well. So I suppose to do the algebra of it, I have it done here faster. If I want to move the minus 4x, I could add 4x to it. That's going to get rid of it. As long as I do it here to the far side, okay, I haven't made a mistake. So they go, okay. Then the 24, if I want rid of that, I could take 24 from it. If I do it to one side, I have to do it to the other. So that's gone. So I'm left with nothing. I've moved those two things. Everything's on one side, but I can tidy it up. Minus 24 plus 9 is the same thing as minus 15. The 4x is positive. That's in my answer. The 3y is positive. That doesn't have to be. It can be positive, negative. And the addition, subtraction sum there, which gives me my final answer. That's the line K. So lots and lots of steps to this, but a big chunk of marks. I had to realize that slope can be found using the y equals mx plus c. If I have the slope of L, I can get the perpendicular slope. Once I have the perpendicular slope, I have a point P. I can use the equation of the line formula to get to my answer. But again, lots of work. Now, the next one here, question 3b, part 2. You have the two different lines, the line L and the line H. Now, this equation has two unknowns. So I can't solve that. I can't solve an equation of two unknowns. But I do have a second equation of the same two unknowns. And there's a methodology here called simultaneous equations, which means if I compare these two equations and join them together, I can end up cancelling one of the variables, and it becomes an equation of one unknown, which I can solve. Now, the classic way of doing this is write them on top of each other. There are different ways of doing it. 2x minus y equals 10. I suppose the simple idea with this method here is I want either the x's or the y's to equal. I'm going to go with the y's here for whatever reason. And I want to make minus y the same size as minus 4y. The only way I can see through that is multiply across the bottom equation by 4. Now, if I write out the top equation, just to keep it handy, well, the bottom equation is going to change. 2x by 4 is 8x, minus y by 4 is minus 4y, 4 by 10 is 40. But I should have changed by the minus as well. I'll have to go again. I should have multiplied by a minus 4, not plus 4. The signs here have to be different from the cancel. So if I multiply the second equation by a minus, minus by a plus here changes to a minus, minus by a minus changes that to a plus, minus by a plus changes that to a minus. Now, once I'm here, I can join the two equations together. So 3x minus 8x is minus 5x. The minus 4y plus 4y are gone. And then 5 take away 40 is negative 35. If I want to find that equation of one unknown, I can solve it now. If I bring the 5 across, it was multiplied on the left, becomes divided on the right. That sum, minus divided by minus is a plus, 25 divided by 5 is 7. So I now know x is 7. Then I can take either equation. I'm going to take the one that looks simpler to me. And because I know that x is equal to 7, I can substitute that in instead of the x, because x is 7. Go left to right and do any things you could do here. I'm just getting the brackets by multiplication. If I see this here, this is an equation of one unknown, so I can solve it. Now I'm going to get rid of the 14 here. I want y on its own, so I'm going to take 14 away. Do it one side, must do it to the other. So that's gone. You're left with minus y is equal to 10, take 14, that's negative 4. Now, I could move these either direction or multiply by minus 1. But if I change all the signs, that's basically what I'm doing. So that becomes plus y and that becomes plus 4. So my coordinates where those two lines intersected was 7 on the x, 4 on the y. And that's the point of intersection. Now, if you're given a graph or you really carefully graph this, you could have done the same thing and just read off the point of intersection. There is another way of doing this where you take one of the equations and you express it in relation to one of the terms. So I could do it here. I could bring the y this side. Go 2x is equal to 10 plus y. And then bring the 10 across. 2x take 10 is equal to y. And then I have an expression for y, okay, the 2x minus 10. I could then take that and put it into the other equation. That's the trick. Okay, so instead of y, I'm going to put in 2x minus 10. Now, once I see this is an equation of one unknown, I can solve this. So going left to right, minus 4 by 2x is minus 8x. Minus 4 by minus 10 is plus 40. Okay, these will combine together. That's minus 5x is equal to, bring the 40 across, becomes 5 minus 40. So minus 5x is equal to minus 35. X is equal to 7. I would just finish off the same way as the last one. Two slightly different ways of approaching the question, but basically we're trying to equate the x and y's, and it only works because we have two equations of the same unknowns. Remember, as an overriding rule in algebra, you can't solve an equation of more than one unknown. That's the answer here, done up in the notes. You see here, I just did a kind of equation grapher of the two lines. You can see they meet at 7 on the x, 6, 7, 8, 7 on the x, then 0, 1, 2, 3, 4, 4 on the y. So it matches up with our calculation. Happy days. I think that's the end of question 3. Okay, so see you on question 4. And if you like the videos, don't forget to subscribe. And if you want a copy of the notes I'm working off, just send me an email at shanetroy@gmail.com. Best of luck.